Hello, Legacy Sabers, Marsh here. So this is video 2 of the semester 1 final packet. This is starting on page 2 of the review packet. We are still on solving systems, unit 2. So we have also graphed systems of linear inequalities. So remember, these ones, you wanted to get it so that it was y equals basically. So y with an inequality. So this first problem right here, I'm going to get it so it's a y on its own. So I do need to move 4x to the other side. So it's going to be a negative 4x plus 2. And then what I'm going to do is I'm going to graph that line. So I'm going to start my y-intercept of 2. And I'm going to go down 4. 1, 2, 3, 4. Right 1. I'm going to follow that just like I normally would. And then what I have to do is I have to think to myself, it is just a less than. So I'm going to give myself a dashed line on this graph. Solid would be if it's an equal to 1. There we go. And now I got to figure out which side am I going to shade. So I'm going to do a check area here. So I'm going to plug in 0, 0, because 0, 0 is on the left here, right? So 4 times 0 plus 0, I want to know if that's less than 2. Well, I'm going to get 0 is less than 2, right? Well, that's true. That's a true statement. So that means I get to shade where 0, 0 exists. So on my line, I'm going to shade this side of my graph. I'm going to change color here so it's easier for us to see the next guy. Now I'm going to color in. I'm going to graph this line. Y is greater than negative 2. That is a line that sits at negative 2. And notice it's another dashed line. So I'm going to do my dashed line here at negative 2. There we go. And now I need my y's to be bigger than negative 2. Where are my lines bigger? My y's bigger than negative 2? They are up here. So my answer region, my solution, is lying in this general vicinity where I colored in my black. Okay. The next unit we covered was on matrices. So on this one, we did some basic matrix operations, multiplication, found determinant, and then we also solved systems, which you could have did on the last video. You could have solved that using matrices if you wanted. I did it using 3x3 elimination because that's kind of what I enjoy. So first thing here, I'm going to do some distribution because this is a scalar multiple. So I'm going to multiply that in. So I'm going to multiply a 2 in. There we go. Now this right here, this negative 3, I recommend multiplying in a negative 3 and then just turning it to positive in the middle. So negative 6, 0, negative 15, and 6. Now I'm just going to add like elements. So 2 plus negative 6 is negative 4. 14 plus 0 is 14. Negative 2 plus negative 17 is negative 17. And 8 plus 6, that's 14. That is my answer. How nice was that? Now, matrix multiplication, remember, first, we check to make sure it worked, because 2 by 2, 2 by 2. The inside told us it worked. Outside told me what answer I'm getting. So I'm going to get a 2-row by 2-column matrix. We multiplied rows times columns. So I'm going to multiply this row times this column. 3 times 1, 3. Negative 1 times 4, negative 4. Okay. This row now times this column is going to go in this particular spot. 3 times 3, 9. Negative 1 times negative 2 is a positive 2. I am done with this row, so now I have to go to this row, but I'm still using these columns. So 5 times 1, 0 times 4. 5 times 3, 0 times negative 2. Final answer, I'm going to actually do some math. 3 minus 4, negative 1. 9 plus 2, 11. 5 plus 0, 5. 15 plus 0, 15. That is my final answer. Last matrices problem is finding a determinant. So remember, when it's a 2 by 2 determinant, you're going to multiply these two, subtract, multiply. So 4 times negative 5 is negative 20. Subtract, it's negative 7 times 8, which is negative 56. So technically, I'm going to have to add. So negative 20 plus 56 is 36 in total. The final problem on this video is absolute value functions. So I had to graph this function for absolute value of x plus 3 quantity minus 6. Now, remember, we started with a transformation table on each of these. This guy had a transformation table because its parent is absolute value of x. Well, I can plug anything into that, right? So I'm going to go -2, -1, 0, 1, and 2. If I plug -2 into the parent, I'm going to get a positive 2, right? Because absolute value makes anything positive. Plug the rest of them in. I now have to take care of my transformations. Remember, this guy is a vertical shift. Vertical shifts multiply your y's, or excuse me, a vertical stretch. This multiplies the y's by that value. This guy was a horizontal shift. And in this case, since it's a positive, remember it's backwards. So we're actually going to shift to the left, which is going to cause my table to subtract 3 from my x values. And the final guy back here, that is a vertical shift. It is exactly how you think it should be. So that is a down shift. So I'm going to subtract 6 from my y's. I now want to know what this new table is. So -3 minus 2 is -5. And then I'm just going to do my math here. There we go. Then I'm going to do 2 times 4. That's 8. Minus 6 is 2. 1 times 4 minus 6 is -2. And then -6. And then since it is a v, it does have some symmetry. So I'm going to put those, I'm just going to copy from the beginning. I now can graph. So -1, 2, 3, 4, 5, 1, 2. Okay, so right there. -4, -2. So right there. -3, -6. So 2, 3, 4, 5, 6. There and there. And then connect the dots. Oop, that was a little wibble wobble. Sorry, guys. Marsh can't draw very well. All right, so my vertex is at -3, -6. I have neither for symmetry. We covered that in our last video, how to find that. Domain, that would be -infinity to infinity. Boundedness, remember, you can be bounded above, you can be bounded below, you can be bounded both above and below, and you can be just not bounded. Bounded means where can you draw a line so that the graph will not cross? Well, I can't draw above, right, because the arms are going to push through, but I could draw an invisible line down here and it wouldn't cross through it. So I'm going to be bounded below on this particular graph. I don't know why I asked for domain again. I don't know. Must have been wanting to really want it that time when I wrote this paper. Increasing intervals, I'm going to do, well, where does it look like I'm going up? Well, it starts at -3, right? And then goes up forever positive. So I'm going to say from -3 to positive infinity. My extrema, that's my min and my max. I have an absolute min on this graph. And it's at the vertex, so that's -3, -6. I do not have any local mins. There's no other valleys on this graph. And I unfortunately have no kind of max either. That includes absolute and local. Intercepts. Well, I do have some kind of y-intercept, don't I? If I would keep using my slope, 1, 2, 3, 4, I would be right here, which is 1, 2, 3, 4, 5, 6. So 0, 6 looks like is one of my intercepts. And then I have some x-intercepts too. They're kind of not perfect. What you could do is we could set equal to 0, like this, and we could start solving if we truly wished. Because remember, to find an x-intercept, you set equal to 0. I'm going to do some guessing. I'm just going to kind of guess what this is. It looks like it's close to -1.25, 0. And it looks like it's close to 1, 2, 3, 4, -4.75 maybe? Probably close. 0. Okay. Continuous. Continuous means that I am starting on one side and I do not have to pick up my pencil to move to the other side. This, in fact, is continuous. My range is -infinity. Oh, not -infinity. I didn't go all the way down there. Silly, silly Marsh. I must have thought I was doing domain again. The lowest I go on this graph is at -6, and I touched it, so I'm going to put a bracket there. And I go forever positive, so going to positive infinity. My concavity, remember, up like a cup or down like a frown. I am up like a cup because it's pointing up. My range, I don't know why I asked for it again. Silly, silly Marsh. And then decreasing intervals, well, I started decreasing at negative infinity. That's the left of the graph. And then I stopped decreasing at the vertex. The x value, remember it's always the x value, -3. That is the end of video number 2. You're going to want to continue on to video number 3 so that you can continue the review packet. Until then, I'll see you later, Sabers.